We've got the equation y plus 2 is equal to negative 2 times x minus 3. And what I want to do is figure out what is the slope of the line that this equation describes. And there's a couple of ways that you can approach it. What my brain wants to do is, well, I know a few forms where it's easy to pick out the slope. For example, if I can manipulate that equation to be in the form y is equal to mx plus b, well then I know that this m here, the coefficient on the x term, well, that's going to be my slope, and b is going to be my y-intercept. We cover that in many other videos. Another option is to get into point slope form. So the general framework or the general template for point slope form is if I have an equation of the form y minus y1 is equal to m times x minus x1, well, then I immediately know that the line that this equation describes is going to have a slope of m, once again. And here, the y-intercept doesn't jump out at you. Let me make sure you can read this over here. The y-intercept doesn't jump out at you, but you know a point that is on this line. In particular, you know that the point x1, y1 is going to be on this line, x1, comma, y1. So let's look at our original example. So it might immediately jump out at you that this is actually in point slope form. You might say, well, okay, I see I have a minus x1, so x1 would be 3. I have my slope here, and that answers our question. Our slope would be negative 2. But here it says plus 2. I have to subtract a y1. Well, you could just rewrite this. So it says, so you have y minus negative 2 is equal to negative 2 times x minus 3. And then you see it's exactly this point slope form right over here. So our slope right over there is negative 2. And then if I were to ask you, well, give me a point that sits on this line, you could say, all right, an x1 would be 3, and a y1 would be negative 2. This point sits on the line. It's not the y-intercept, but it's a point on the line, and we know the slope is negative 2. Now, another way to approach this is to just manipulate it so that we get into slope-intercept form. So let's do that. Let's manipulate it so we get into slope-intercept form. So the first thing my brain wants to do is distribute this negative 2. And if I do that, I get y plus 2 is equal to negative 2x, negative 2 times negative 3, plus 6. And then I can subtract 2 from both sides. And then I get y is equal to negative 2x plus 4. And so here I am in slope y-intercept form. And once again, I could say, all right, my m here, the coefficient on the x term, is my slope. So my slope is negative 2. Let's do another example. So here, this equation doesn't immediately go into either one of these forms. So let's manipulate it. And if it's in either one of them, I like to get into slope y-intercept form. It's a little bit easier for my brain to understand. So let's do that. So let us collect, well, let's get the x's, let's just isolate the y on the right-hand side since the 2y is already there. So let's add 3 to both sides. I'm just trying to get rid of this negative 3. So if we add 3 to both sides, on the left-hand side, we have negative 4x plus 10 is equal to 2y. These cancel out. That was the whole point. And now to solve for y, we just have to divide both sides by 2. So if we divide everything by 2, we get negative 2x plus 5 is equal to y. So this is in slope-intercept form. I just have the y on the right-hand side instead of the left-hand side. But you have y is equal to mx plus b. And so our m is the coefficient on the x term right over here. So our slope is once again is negative 2. And here our y-intercept is 5 in case we wanted to know it. Let's do one more example. One more example. All right. So once again, this is in neither slope-intercept or point slope form to begin with. So let's just try to get it to slope-intercept form. And like always, pause the video and see if you can figure it out yourself. All right. So let's get all the y's on the left-hand side isolated and the x's on the right-hand side. So let me get rid of this negative 3x. So I'm going to add 3x to both sides. And let's get rid of this 3y right over here. So let's subtract 3y from both sides. You could view this, I'm doing two steps at once, but once again, I'm trying to get rid of this 3x. So I'm trying to get rid of this negative 3x. So I add 3x to the left, but I have to do it to the right if I want to maintain the equality. And if I want to get rid of this 3y, well, I subtract 3y from here, but I have to do it on the left-hand side if I want to maintain the equality. So what do I get? That cancels out. 5y minus 3y is 2y is equal to 2x plus 3x is 5x. And then these two characters cancel out. And so if I want to solve for y, I just divide both sides by 2, and I get y is equal to 5 halves x, and I'm done. And you might say, wait, this doesn't look exactly like slope-intercept form. Where's my b? Well, your b, if you wanted to see it, you could just write plus 0. b is implicitly 0 right over here. So your slope is going to be the coefficient on the x term. It's going to be 5 halves. And if you want to know your y-intercept, well, it's 0. When x is 0, y is 0.